In this video, we're going to do another example involving the integral test. So we're being asked here to determine whether the series from 2 to infinity of 1 over n times natural log of n quantity squared is convergent or divergent. So we'll let the function f be 1 over x times log x quantity squared. Notice in this case the series going from 2 to infinity because we don't want to plug in 1 for n here because that would give us a 0 in the denominator. But as long as our x is 2 or greater, certainly here we're not going to get any negative numbers, so it'll be continuous. We're not going to get any zeros in the denominator, so it'll be positive. And certainly as x gets bigger, both x and log x get large, so this whole thing will get small. So it's continuous, positive, and decreasing on the interval from 2 to infinity. So we'll apply the integral test here, take our improper integral of the function. Here we need to do a u substitution to be able to find an antiderivative, if you don't see it right away at least. We'll let u equal log x, so then your du is exactly what you have in front here, the 1 over x dx. So we do the substitution, we'll get 1 over u squared. Now, of course, everything here is in terms of u, so we better make our limits in terms of u. If you plug in 2 for x, you get log of 2 for u. If you plug in b for x, you get log of b for u. So our integral goes from log 2 to log b. Antiderivative of 1 over u squared is negative 1 over u. Evaluated from natural log of 2 to natural log of b. Plug those values in, so we'll get negative 1 over log b. You get minus a minus 1 over log 2. And now as b gets really, really large, natural log of b also gets very, very large, so this first term goes to 0. So the limit turns out to be 1 over log 2. Now again, doesn't matter what the value is, it just matters that the limit exists. Since the limit exists, the integral converges, so the series also converges by the integral test.